Welcome a student in my third lecture on acid soil, and in previous two lectures I have already discussed about the causes of the development of soil acidity, second impact of soil acidity on nutrients availability to the plant system, and third most important soil reaction when lime applied in the soil system, what type of reaction takes place to neutralize aluminum and hydrogen ion, and also options for the management. First option is the application of lime and second option is the selection of the acid tolerant variety. This part I have already covered for you in previous two classes. Today I would like to start my lecture with a most important topic, that is called acid sulfate soil. Actually this is a unique type of the soil acidity mainly developed in the coastal area, and mostly this type of the soil found in the Kerala state, and this is a soil formed by the oxidation of the sulfur in the coastal area, developed by the drainage of the coastal marshes and swampy that contain pyrite, which is oxidized, resulting produce of the sulfuric acid. As you know, sulfuric acid is a strong acid. When this type of acid produced due to the oxidation, our soil pH goes 2 or 3. So this is a most important soil acidity problem, especially found in the coastal area. Now, for management option, first management option is application of the lime. So, what type of lime we can use for the control of the soil acidity? Actually, there are two methods. One method to apply lime by in whole plots by broadcasting, and second application is behind the furrow on the basis of lime requirement. Actually this research has been done in my center, at my center, by Dr. M.S. Mathur, and he has advocated for economically, if we neutralize the rhizosphere zone of the crop, we can get same benefit as equal to the broadcasting application of the lime. In broadcasting application, we have to apply 40 to 50 quintal lime per hectare, but in the furrow application it is very economical. We have to reduce that dose up to 4 to 5 quintal per hectare, and this is very economical, and our poor resource farmers can adopt this technology. So most of the common liming material are finely ground limestone, a material composed of the varying concentration of the calcium and magnesium carbonate, as for example calcite and magnetite. Dolomite, and limestone has all the desired character of the agricultural liming material. This calcite is an ideal liming material for neutralizing the acid soil. Now, quick lime, burnt lime on oxidized lime, this is the CaO, and this calcium oxide produced by the heat treatment on the calcium carbonate. This is the calcite, and calcium oxide is produced, and CO2 is the escape in the atmosphere. So it is 1.7 times more reactive than the calcium carbonate and could be 3 times more effective at neutralizing soil acidity than ground limestone. Now, hydrated lime, calcium hydroxide, it is 1.35 times more reactive as compared to the pure calcium carbonate and could be twice effective at neutralizing the soil acidity than ground limestone. Now, third is the Oster shell. Actually, shell is comprises or formed by the calcium carbonate. So, this shell, if we apply up to in the form of powder, it is also as effective calcium carbonate also. So, eggshell are equally, they have about 60% CaC, calcium carbonate equivalent. Since eggshell are crystalline carbonate like limestone, they are ineffective at neutralizing soil acidity unless they are finely ground. Basic slag also produced in the steel industry. It is a waste material. It also contains a sufficient some amount of the calcium, and so many research have been done by the different institutions, and they have reported this calcium basic slag can also utilize as a liming material in the acid soil, and its neutralizing value is 8.6. Now, what are the factors influence lime quality? Actually, first is its neutralizing capacity. In earlier slide, you have seen different type of the liming material have different neutralizing capacity, as like calcium carbonate, calcium oxide is the higher neutralizing capacity, calcium hydroxide and other cells. The fineness to which it is ground, what is the mesh size of the our product. Now, acid neutralizing capacity usually measured as calcium carbonate equivalent, CCE. CCE is the acid neutralizing capacity of a liming material expressed as percent by weight of the pure carbonate, or you can say it is a compare how much our liming material effective as compared to the calcite of calcium carbonate. Pure calcite has CC of 100%. Now, factor affecting the reactivity of the lime, it is the most important, as it increase the use efficiency of our applied liming material. First is the purity expressed as the percentage. Second is the fineness based on the mesh side. If our size is the small, then effectiveness is the more. Neutralizing value of the different liming material, if neutralizing value is more, then that liming material is more effective to neutralize the soil acidity. Now, degree of mixing and reaction time, it is the most important, how much your liming material will mix with the soil system, and what are the reaction time, what are the time our farmers providing to neutralize, to complete the reaction in the soil system. Now, degree of mixing and reaction time, lime is a very insoluble and it needs to be mixed throughout the root zone. If limestone properly mixed with the soil, planting may be done without delaying, because enough fine particle of the lime present in the rhizosphere zone to raise the soil pH, minimize the toxicity impact of the ammonium and H ion also, and also to correct the calcium deficiency. Now, we reach at option 2. I have in previous classes I have discussed there are two options. One is the application of the lime and second is the selection of the acid tolerant crops. So this is also most important. Different plant species, even variety within a species, grow best at different pH range. And for example, pineapple grow best at the pH below 5.7 and suffer from the iron or Mn deficiency at higher pH range. Now, soil reaction preferred for different crops. This is the soil pH range, and these are the some crops. You can see oats can be grow successfully from 5 to 7.7 pH, just like maize, sorghum, wheat, barley. Our farmers can successfully grow at 6 to 7 pH, and this is the millets, and this is the rice, is the very acid tolerant crops, and it can be grow up to 4 to 6 pm, and in the rice case, due to the submergence, water also act as a learning material. Now these are the also some selected crops we can grow successfully at different pH range. Now this is my mail, this is my cell phone, and you are free to interact on any doubt in previous lecture and also today lecture on my mail and on my mobile. Thank you, and in last I would like to give you a message. See, this soil's health, if our soil health will be maintained, it can transfer a lot of nutrients through the plant system, will reach in the human plate, and our human health will be maintained. Thank you.